We're going to continue with our same instructions of finding the limit if it exists. And if we see that unbounded behavior, then we will describe it with infinity. So this time we're going to look at some algebraic expressions. So we'll look at the limit as x approaches 2 from the left. Well, as always, we want to try direct substitution. So I'm going to put in 2 for my x values. And this time I'm not going to get an indeterminate, but I am going to get that indicator that I've got something unusual going on. So as I plug in my 2 for all the x's, in the numerator, I get 4 plus 4 minus 3, and that's going to give me 5. In my denominator, I'll have 4 plus 2, which is 6, minus 6, which is 0. So I get that description of 5 over 0 as an indicator that I've got some kind of unbounded behavior going on. So I'm going to do some algebra. I'm going to look at the limit as x approaches 2 from the left and factoring the numerator. Now remember, for factoring, I don't need to see your split the middle process. I do need to see the factors that you get as a result. So the factors that you would get for x squared plus 2x minus 3 would be x plus 3 and x minus 1. And in the denominator, the factors that you would get for x squared plus x minus 6 would be x plus 3 and x minus 2. So you can see that we could simplify, canceling the common factor of x plus 3, so that now we could do the limit as x approaches 2 from the left of x minus 1 over x minus 2. All right, so still, and I can just think about this in my head, if I substitute in 2, I'm going to get a non-zero number on top. I'll get 1, and I'll get 0 in the denominator. So I know that I've got an infinite limit. Now I want to know, is that limit approaching positive or negative infinity? So since I'm approaching 2 from the left, and I already know that it's unbounded, I'm going to use a number that is slightly smaller than 2. I'm approaching from the left, so I'm just going to use 1.99. So 1.99 minus 1, and in the denominator, 1.99 minus 2. Now, I'm not really interested in those numerical values, but I'm looking at the sign. So if I take 1.99 minus 1, I'll get a positive answer. If I take 1.99 minus 2, I'll get a negative. So from the left, I'm getting a positive over a negative, and I know it's unbounded. So that means that my unbounded behavior is actually negative, and it'll be negative infinity. So the limit, the original limit is going to, and I want to say in quotes, equal negative infinity. The limit really doesn't exist, but what's going on from 2 to the left is that it's approaching negative infinity. All right, now let's take a look at the second one at D on this page. So you have the limit as x approaches 1 from the right of x squared plus x plus 1, and then in your denominator, you have x to the third minus 1. So again, I'll try doing the direct substitution. So substituting in, I'll have 1 squared plus 1 over 1 to the third minus 1. And so I get 3 over 0. So I can see that something unusual is happening. So I'm going to go ahead and see if I can factor and simplify this any at all. So I'll do the limit as x approaches 1 from the right. The numerator is prime. I cannot factor x squared plus x plus 1. However, my denominator is a difference of 2 cubes. So that would factor to x minus 1. That would be your a minus b. And then it's a squared, so that would be x squared. And then you do a sign change. So it'd be plus a times b, which is 1x in this case, or just x. Taught a little bit too much Algebra 1 there. And then your b squared, which would be plus 1. And so you can simplify that expression, canceling your numerator, which still leaves a 1, and your denominator. So now what you're investigating is the limit as x approaches 1 from the right of 1 over x minus 1. And once again, I simplified this because it's a lot easier for me to substitute in a number at this point to find out what kind of infinity is going on as I approach 1 from the right. So 1 from the right, I'm going to use a number just a little bit bigger than 1. So 1 over 1.001 minus 1. All right, again, I'm only concerned about the signs. This would be a positive on top and a positive on the bottom. So from the right, this function is going to positive infinity. Now, again, I want to emphasize why I did the factoring. I did the factoring because this was a lot easier calculation for me to do than trying to figure out what is going on in a little bit more complicated expression, substituting in a decimal value. So here we have that this limit, even though it does not exist, is described by positive infinity. Now, part E is the exact same function. However, we're looking at x approaching 1 from the left. So I don't need to redo all of the work that I did with my factoring. I just need to redo my thinking right here. So the limit as x approaches 1 from the left of this more simplified function, 1 over x minus 1. This time I can substitute in a number slightly smaller than 1. So 0.999 would be fine. And subtract 1. Again, looking only at the signs. So my numerator is positive. My denominator this time, though, is negative. So that is describing a negative unbounded behavior. And so this limit can be described as negative infinity as I look at approaching 1 from the left. So you have that difference in the two sides of 1 shown in parts D and E. And so I'll erase and look at part F, which is a trig function, so that you can see the investigation for a problem like that. All right, so for part F, we have the limit as x approaches 0 from the left of 2 over the sine of x. So doing our direct substitution, we can put in 0 for the x. So we would have 2 over the sine of 0. Well, the sine of 0 is 0. Remember, that's the angle that is on your unit circle. That is your starting angle at the ordered pair 1, 0, and your sine is your y value. So that would be 2 over the sine of 0 would be 2 over 0. So now we have to figure out what is happening with this graph from the left. So you might have to think about your unit circle just a little bit and what is going on with that. So let me draw my fabulous unit circle here. Here is angle 0. And since we are approaching from the left, then we're thinking about angles that would be that are negative angles. Okay, well, negative angles, since we were approaching 0 from the left, negative angles would occur then in the fourth quadrant. And in the fourth quadrant, let's think about what your ordered pairs look like. Well, your ordered pairs in the fourth quadrant, the x is positive, but the y is negative. And since sine is the y value, then sine is negative as you approach 0 from the left. So as you look at this, you have positive for the 2, but you have negative for the 0. And so even though this limit does not exist, we can describe what's going on as negative infinity. And this one might be a good one to just take a look at Desmos. Sometimes we aren't quite as familiar with this type of graph. So I'll bring up Desmos and let you see what that graph is going to look like. I'll have to get rid of my writing. So let me erase and just take a quick look at this graph. So your graph y equals 2 divided by the sine of x. And so you can see that what we're interested in, I get rid of that writing. What we're interested in is what is happening as x is approaching 0 from the left. So as x is approaching 0 from the left, so here's 0, and approaching 0 from the left, you can see that graph is going to negative infinity. So this will be the end of video 2. We have one more to look at, vertical asymptotes.